Hello, and welcome to APICS Extra Live, Constructing a Probability-Based Cycle Counting System. Dr. David F. Ross, CFPIM, CSCP. My name is Jennifer Storelli, Associate Editor at APICS. Before we begin, I'd like to run through a few details. At the end of the presentation, we will save time for a question and answer session. If you look at the right toolbar on your screen, you'll see a questions box. To ask a question at any time during the presentation, simply type it in the box and click Send. Should you experience any technical difficulties during today's broadcast, please call GoToWebinar Tech Support at 1-805-617-7000. Again, that's 1-805-617-7000. This presentation is being recorded and will be available at apics.org/extralive early next week. And now it's my pleasure to introduce our speaker for today. Dr. David F. Ross, CFPIM, CSCP, is Senior Manager of Professional Development at APICS and author of the September-October 2016 APICS Magazine article, Cycle Counting by the Probabilities, which is available in print, online, and through the APICS Magazine tablet app. Everyone, please give a warm welcome to David. David, you may begin.
Thanks, Jennifer. Again, I'd like to quickly introduce myself to you. Again, as Jennifer mentioned, I'm David F. Ross, and I'm the Senior Manager of Professional Development here at Corporate. I've been here for almost 7 years. I have over 35 years in industry and consulting and ERP education, professional development, and other types of experiences. I've held faculty posts at Northwestern University's Kellogg School of Management and Elmhurst College. I've been an APICS member since 1985, and I'm recognized by APICS as CFPIM and CSCP. I am finally a recognized author in the field of supply chain management. I've published 7 books in the field, 2 of which are used as primary references in the CPIM, CSCP, and CLTD certification programs. Let's begin by looking at the presentation's objectives. All companies seek to have the highest level of inventory accuracy as possible. Ensuring the accuracy of inventory enables companies to effectively leverage their inventory investment to provide the highest levels of customer service at the lowest cost. Companies must have inventory to do business. More isn't always better, nor is less always better. However, knowing how much inventory you have and need to operate your business is always better. This presentation is about the methods the inventory control function and a typical company can use to audit the accuracy of their inventories. When it is considered that many companies have inventories consisting of tens of thousands, even hundreds of thousands of stocked items, keeping them as accurate as possible is of the utmost importance. In this presentation, we'll be discussing the following points: defining inventory, detailing the objectives of inventory management, defining cycle counting, discussing cycle counting methods, determining cycle count frequency, applying item balance probability to cycle counts, calculating the cycle count, detailing cycle counting steps, and finally detailing the advantages of cycle counting. Let's begin by defining inventory and inventory management. According to the APICS dictionary, inventory is defined as those stocks or items used to support production, raw materials and work in process items, supporting activities, maintenance, repair, and operating supplies, and customer service, finished goods, and spare parts. The nature and task of inventory management is defined as inventory management is responsible for the timely replenishment of inventories and the accurate and timely status of on-hand balances, on-order quantities, and the financial value of finished goods, components, and raw materials physically present at stocking locations. These definitions describe inventories being created with the receipt of materials, components, or finished goods into the business, either through purchasing or production. Inventory management is the name for the business function charged with the ordering, control, and disbursement of inventory to production, the supply channel, and the customer over time. It is important to note that inventories, regardless of whether they are for production, distribution, or service, do not exist in a vacuum. They are required to perform several functions, and it is the role of inventory management to ensure that items are accurately ordered and maintained to match their intended objectives. Supporting the basic goal of providing the highest customer service at the minimal inventory cost, inventory management has the following four major supporting sub-goals. First, customer service. Good inventory management prevents stockouts. Inventory managers investigate and resolve issues causing high demand and supply variability stemming from such events as inaccurate forecasts, materials and component shortages, inadequate shop floor scheduling, high scrap, poor communications, inaccurate information, and faulty processes. The negative effect of uncertainties caused by these and other factors is higher inventory levels. Cost reduction. Since inventories are a major capital cost, a critical objective of inventory managers is continuous cost reduction without accompanying reductions in customer service levels. This is a difficult objective to achieve, involving decisions such as weighing make or buy alternatives, defining lead times and process cycles, reducing scrap, and others. Process efficiency. Effective inventory management enhances the efficient use of the production workforce and equipment to meet customer responsiveness targets. Proper inventory planning enables resource optimization, ability to make quick changeovers, and scalability of resources based on demand. At the same time, effective inventory management reduces overtime costs, cycles of employee layoffs and rehires, and premium purchase order and transportation costs. And finally, capital budgets. Effective inventory control enables companies to realize inventory as well as a range of linked departmental budget objectives. Inventory expenditures are matched periodically to the capital expense plan to obtain return on investment measurements, analyze variances, and provide a basis for corrective action. In addition, as inventory stock outs decline, sales is able to make its revenue numbers. Finance is able to more effectively plan for cash flow, and operations is able to reduce the costs associated with overtime, expediting, and uncertainty. All of the sophisticated inventory ordering techniques and performance measurements are meaningless unless a firm can maintain as close to 100% inventory record accuracy as is possible. Without a serious and detailed plan to control the physical movement of inventories, on-hand balance inaccuracies can drain profitability and inhibit effective financial performance. In addition to the impact on financial measurements, poor customer serviceability usually accompanies inaccurate inventories. The litany of performance problems is familiar: declining order volumes and high customer turnover, increasing back orders and order cancellations, increasing inventories and expediting costs, significant inventory inequalities in the supply channel, growing inventory obsolescence, and increasing costs for expedited purchase orders and freight. Regrettably, not one, but all of these conditions are usually experienced at the same time by companies with poorly managed inventories. Ineffective inventory control destroys the confidence of the firm to establish meaningful plans and performance measurements, and to respond effectively to competitive marketplace challenges. Perhaps the most important question to ask in this presentation is then, what exactly is inventory accuracy? The definition of inventory accuracy appearing on Visual 7 is from the APICS Dictionary. An important part of the definition is concerned with what is meant by the term accuracy. In an absolute sense, Accuracy means that a statement about a relation of entities possesses 100% truth or conforms without variance to a standard. When it comes to the management of inventories, however, absolute accuracy may not always be possible or even necessary. It is important to understand that the term accuracy, when applied to inventory management, is best described as the degree of conformity of a measure to a standard or a true value. The key is determining for each item in an inventory the degree of accuracy necessary for the item to perform according to the parameters of the processes in which it is used. For example, machined metal parts may be considered as being accurately made even though their dimensions may exhibit a slight variance. Every machine produces these variances from the specification, but as long as the items do not deviate from the specs more than a certain amount, we think of them as accurately made. In an ideal world, inventory accuracy would be the norm, but in reality, perfection is not necessary or achievable. Inventory records in the manufacturing or distribution environment can be acceptable or accurate without being perfect. As indicated in the APICS definition, the measurement of inventory records and the tolerances established to determine acceptable accuracy is usually expressed as spanning the range of 95% to 99% accuracy. While inventory tolerances help inventory control to determine the existing state of inventory accuracy, the real effort should be placed on establishing and following through on inventory accuracy improvement. Inventory control is a number of improvement and control techniques to report on and increase inventory accuracy. Visual 8 lists the most commonly used. First of all, the effective and identification of the management of the 3 Ps of inventory control. The 3 Ps are the people, places, and paper involved in executing inventory transaction management. The first is people. Effective inventory control centers on the people in the organization charged with its maintenance. Have the right people been assigned to maintain inventory accuracy? Have they been given authority to make it happen? Have they received the necessary training with techniques and systems? The second P is places. The places and critical process steps where inventory transactions occur must be carefully identified and adequately staffed and constantly verified to prevent inaccuracies. Inventory managers must identify critical points of inventory transaction reporting and put into place the proper people and equipment to make high inventory accuracy possible. And finally, the last P is paper. Proper documentation must accompany transactions at each transaction point. Paperwork should be easy to use and permit complete recording of transactions in the inventory control system on a timely basis. Today's computerized inventory management systems have dramatically cut the amount of actual paperwork needed to manage inventories. Second toolkit is detailing transaction management. The goal is the identification and development of transaction procedures to ensure that all movements occurring in the inventory are recorded in an accurate and timely manner. Identification of transaction control points enables inventory managers to reduce inventory loss and vastly improve accuracies. Managers must closely map the flow of inventory to the organization, noting each point where inventory balance, financial, and location records must be updated through a system transaction. Third, defining the purpose and procedures of the annual physical. The APICS dictionary defines the year-end physical as a physical inventory taken at some recurring interval, such as month, quarterly, or annual. The exact timing of a physical often depends on the nature of the business and the size of the inventory, and is usually linked to the business's financial year-end. Some industries that have very expensive items, such as high-tech, may perform a complete review of all item inventory balances once a quarter or even once a month. Companies that are publicly traded in the U.S., for example, are required to perform a physical at least yearly. This requirement, however, can be waived if a firm has a certified cycle counting program from its financial auditors. Next is utilizing state-of-the-art technology tools that accelerate and ensure the accuracy of transactions. Most variances in inventory balances are the result of human error and are a result of a neglect to enter inventory transactions accurately, on time, selection of wrong items, choice of wrong transaction codes, and faulty reading of documents, and so on. The application of technology tools to assist inventory management personnel is focused on how to remove these elements of human error from the process. Two critical areas of technology tools for inventory control stand out. One, expanding use of warehouse automation tools to reduce error, increase productivity, and speed up the supply of the supply chain. And second, the implementation of integrated software suites for warehouse management, labor and task planning, slotting and carton solutions, and yard management. The most important electronic data collection tools now in use are barcodes, auto ID, RFID, global positioning systems, or GPS, and quick response. Another set of tools are packing and containerization, allocation and auto order backflushing, picking automation through handheld devices, speech recognition, and pick to light, universal product code tagging and special labeling, pallet management and conveyors, sorting and picking systems, and finally automated storage and retrieval systems. While these technology tools can be costly to purchase and implement, companies can quickly recover their costs through increases in inventory accuracy. And finally, the last critical tool is defining and executing an effective cycle counting program. A full definition of cycle counting is found in the APICS dictionary and is visible on the next visual. Let's review the major points of the definition of cycle count detailed from the APICS dictionary. The first major point is that cycle counting is a system of counting inventory continually throughout the year, not just once a year, like happens in the annual physical. Cycle counting involves counting items on an assigned, reoccurring basis, often more frequently for high-value or fast-moving items, and less frequently for low-value or slow-moving items. The rationale behind the technique assumes that the more an item is transacted through time, the greater the probability that errors will occur. Another important part of the definition is that cycle count normally requires that a set number of items be counted each day. Furthermore, cycle counting enables inventory control to identify variances between booked and physical quantities each day and to make the necessary adjustments to reconcile the discrepancies. And finally, the most important objective of cycle counting is the application of an unflagging research, identification, and elimination of the root cause of the errors so that they will not occur again. The cycle counting function should be conceived as a closed-loop process. The goal of the process is to begin with a baseline set of inventory accuracy objectives, and then to progress to increasing levels of inventory accuracy through controlled process iteration. As illustrated in Visual 10, cycle counting should be understood as a closed-loop process comprised of the following steps. First, determine the current state of inventory integrity and set target levels of inventory accuracy. The cycle counting process begins with the determination of the current state of inventory integrity. This activity assesses the stability of the current inventory control system. Once the parameters of inventory integrity have been defined and established, inventory control should be able to determine the current level of inventory accuracy. Finally, a realistic target level of inventory accuracy is formulated. Also, inventory control should establish what cycle counting method is to be used. How many items are to be counted each day? What is their recurring cycle? What procedures govern how the cycle count is to be performed? And the count teams involved. Cycle count itself. The cycle count process then begins. In summary, a select number of items is counted each day. Third, tracking of variance causes. Each day, the results of the cycle count are submitted to the inventory variance tracking team. This team is responsible for assembling the results, comparing the physical counts with the book balances, identifying which counts are acceptable and which are unacceptable, investigating and assigning reason codes for all variances found, performing reconciliation transaction updates, working with warehouse management to determine the root cause of all variances found, selecting items for recount, and preparing the next day's cycle counts. The fourth step is accuracy level. As the cycle counting process proceeds through time, inventory control must determine the accuracy of the items counted. The goal is to see inventory accuracy levels rise through time as the cycle counting process takes firm root in the organization. It is important to note that accuracy and stockout is two different things. Class C items can have a lower target percent, but that does not mean that they are stocked out. And finally, compare the current accuracy levels to the target accuracy. Hopefully, the ongoing results of the cycle counting program will enable inventory control to establish higher inventory accuracy targets. When a new target is established, it will impact the contents of the existing count process, thereby requiring any necessary changes in items to be counted. An important part of designing the cycle counting system is determining which or a combination of methods should be used. The method will determine how the cycle count will be performed. The most widely used methods are as follows. The ABC method. ABC is the most popular. This method is based on an effective ABC item classification. The mechanics of this process consist in establishing a cycle count frequency for each of the ABC classifications. For example, high value or fast-moving products are classified as A and are reviewed more often than low value or slow-moving items. An example of the ABC method is to count all Class A items monthly, all Class Bs quarterly, and all Class Cs twice a year. Zone method. In some cases, items are stored in specific zones due to their physical properties, the nature of the storage area, or other factors. An example is a frozen food zone in a produce warehouse. Since all items in the zone have a fixed location, the cycle count schedule starts with the first location and continues daily until it reaches the last location. At this point, the count begins again at the first location. The location audit method. Cycle counting becomes difficult in warehouses where items are stocked randomly. The location audit solves this problem by cycle counting a set number of locations in the warehouse each day. When the whole warehouse is completed, the count begins again at the first warehouse location. And finally, we have methods associated with being transaction-driven. An item transaction event is used to initiate a cycle count, and examples include such things as when a replenishment order is placed or received, when inventory is at negative or zero balance, at the time of the demand order pick, after a set number of transactions, and finally, when an inventory shortage is identified. Once the method or combination of methods has been selected, the next step is to determine the cycle count frequency. While there are several cycle counting methods available, the ABC classification method is the one most commonly used. Here, cycle counts are established for groups of items belonging to an individual ABC classification. Because of its prevalence, the ABC method will be the focus of the rest of this presentation. An effective cycle counting program deploying the ABC method contains 4 critical drivers. First is the item classification, and this separates the item database into groups based on such criteria as transactions, value, and the like. Inventory accuracy targets. These, such as a 98 or 99%, are associated with each classification. Cycle count interval determines when and how many items in the classification are counted as complete. And finally, the probability of variance describes the chance that an item will experience a count discrepancy during a complete cycle count. Variance means an inventory count that violates, either positively or negatively, quantity tolerance values. Regrettably, many classical ABC methods descriptions are incomplete, omitting some of these drivers from the analysis. A typical example is seen on Visual 13, which illustrates a total inventory consisting of 10,000 items grouped by ABC classification. A count interval for each class has been established, such as weekly or monthly for A items, bi-monthly or quarterly for B items, and so on. Then the number of counts to be performed yearly, weekly, and daily are then calculated. For example, as shown on the worksheet on Visual 13, there are 2,008 items are counted 12 times a year. The result would be a total of 24,000 item counts. This model has many shortcomings. To begin with, it results in a static model for managing inventory accuracy because, once established, the count intervals and number of counts in each interval remain fixed in time. The reality is that the factor determining when an item class should be reviewed depends on the likelihood of an inventory discrepancy. In fact, it is the probability of item variance that should drive a cycle counting program. A static system is a serious problem if inventory accuracy declines. In such a case, the count interval should narrow and daily counts increase so that items are counted as complete in a shorter time frame. The opposite also is true. If inventory accuracy increases, the count interval will widen and the number of items counted will decline. Furthermore, the conventional model does not consider that each classification will have its own inventory accuracy target. Because A items will have a higher accuracy target than slow-moving C items, they should be counted more often. Now that the importance of item variance probability has been established, the next critical issue becomes determining the cycle count frequency and quantity. An essential component in the creation of effective cycle counting is determining the cycle count frequency. The cycle count frequency is defined as the interval of time separating the physical counting of the inventory of an item. Obviously, the more times an item's inventory balance is reviewed and corrective action taken to eliminate the source of variances, the greater the inventory accuracy. For almost all manufacturers, distributors, and retailers, however, counting every item as much as possible is not only not possible, but unnecessary. With this being said, the critical question becomes, what should be the review frequency for an effective cycle counting program? Visual 14 describes 3 possible methods. 1. Progress-based. In this model, normally used zone and location audit cycle counting methods, items in a set number of warehouse locations are counted daily. Often termed the block method, the cycle counter literally takes a wall-to-wall inventory of all items in a set series of specified storage locations. The counter counts everything found, whether or not the items are on the cycle count worksheet, within a predefined time span. When all the locations within the zone have been counted, the process begins again with the first series of locations. The advantage of this method is that all items within the warehouse are given equal weight, and it provides an excellent tool for finding inventory that is misplaced or no longer stocked. A second method is a heuristic. The disadvantages of the block method are that low transaction items are treated the same as high transaction items, with the result that the interval between the review cycle of the vital few items in the inventory is way too long, and considerable time and energy is spent reviewing items with low transactions and accompanying low probability of inventory inaccuracy. The way to overcome these drawbacks is to segregate the inventory into classes based on their probability of inaccuracy. The interval determining the cycle count frequency is established by applying a reasonable heuristic or calculated mathematically. An example of the use of such a simple heuristic is the policy that all Class A items are counted once each month, all Class Bs are counted 4 times a year, and Class Cs are counted twice a year. The drawback to a heuristically determined interval is that it may be insensitive to the probability that the inventory interval will change through time as inventory accuracy improves or declines. And finally, the third method, and the one that we're going to be exploring, is probability-based. The solution to the problems associated with a heuristic is to use the same division of items into classes, but then to add 2 additional factors. First, a targeted inventory accuracy %, and second, the probability that a stock variance will occur within that class. These factors can then be used in a formula to determine the review interval. There is an important relationship between the probability of an item variance, the cycle counting period length, and the level of inventory accuracy. Without a doubt, the key is understanding the probability of item variance. If 10,000 items experience the physical count, and all 10,000 exactly corresponded to the book inventory balances, the level of inventory accuracy is 100%. If such a situation occurred, there would be no reason for a cycle count, since the probability of a variance occurring over time is 0. However, if the physical count revealed that 200 out of the 10,000 items had variances, it is said that we would have 200 chances out of 10,000 of discovering a given variance. This dynamic enables the formulation of 3 critical corollaries about the concept of cycle counting. First, regardless of the opening level of inventory accuracy, if cycle counting is performed at a given rate and the probability of item variances remain constant, the accuracy level in the system rapidly approaches a constant value. This means that if the probability of item variance remains unchanged and the number of items counted in the cycle count remains constant, the level of inventory accuracy will rapidly increase, but then will reach a constant. And this is a problem that has occurred with the heuristic model. Second corollary is if cycle counting is performed at a given rate and the probability of item variance decreases, the inventory accuracy level will correspondingly increase. This means that if the results of a cycle count are used to decrease the number of item variances occurring, the level of inventory accuracy will continuously increase in proportion to the decrease in the number of count variances. And finally, the last corollary, as the probability of item variances decreases, the time interval between counting an item correspondingly increases. This means that as item variances decrease, the probability of future occurrences of variances for those items will likewise decrease. This is so because as more of the items counted in a given population approach 100% accuracy, the less those items will need to be cycle counted. Inventory control can use a simple formula to arrive at the cycle count frequency for a given population of items. There are two key components of the formula. First is determining the accuracy level desired. The first of these 2 points, again, is establishing a desired accuracy level per classification. Inventory control must establish the target inventory as a percent. For example, inventory control may establish the following targets for an ABC cycle counting method. Class A items must have a 99% accuracy target, Class B a 98%, and Class C a 96% accuracy level. The second key is tracking the probability of a variance. The probability of item variance is determined by assessing how many variances for a given population of items have occurred over a given time period. This number is first established by performing a physical count of the target item population. For example, if 1,000 items were counted over a week's time and counters found that 100 of the items in that population exhibited a variance from the booked inventory balance, there is a probability that the item population will continuously exhibit a 10%, or 100 divided by 1,000, possibility of item variance each week for the 1,000 items. Once these two components have been determined, inventory control can establish the cycle count interval for the 1,000 items using the formula found at the bottom of this visual. Let's investigate the components of the formula. The numerator is expressed as 1 minus the accuracy level desired. The denominator is expressed as the accuracy desired times the variance probability. Let's see how this formula would work in an example. The following data will be used in our calculation. And here are the base data elements. The accuracy level desired is 99%. The number of items to be considered is 1,000. The probability of items with variances, there have been 100 items that have been found to have a variance within within a week's time. Now let's review how the formula would be applied to the data. The result is that all 1,000 items will have to be counted in a 1-month cycle. So you can see the numbers up there, very simple input of the data into the base formula, resulting in a 1.01 cycle. Let's look at a more detailed example. To start the cycle count process, inventory control has just completed a cycle count of their full inventory of 10,000 items. The results were then organized in a spreadsheet displayed on Visual 18. Once the counts were completed, it was found that 1,000 items had a variance. Next, the variances were separated by ABC classification. Next, each of the 3 classes was assigned a target inventory percent. This percent was the value the company wished to achieve to support its strategic inventory plan. Next, the probability of error is calculated. As determined in the visual, the accuracy of the 10,000 items is about 90%, or 1,000 divided by 10,000. This means that about 10% times 10,000 items divided by 50 weeks, since we're going to be looking at our cycle counts in terms of weeks, in the working year, or a variance probability of 20 units per week is detected for each class of items each week. Once the variance probability has been identified, it is then possible to calculate the count frequency per week by applying the count frequency formula. A critical part of this calculation is identifying the target accuracy percent linked to each classification. For example, to determine the count frequency for Class A items, in the example, requires using the target accuracy of 99% in the formula as follows. And we can see that on the display, meaning that our cycle count frequency would have to be reoccurring a little over each 5 weeks. This translates into a total of 9.9 complete cycles a year. Each cycle consists of a total of 396 items counted per week and 79 per day. If a counter can count an average of 40 items per day, this means that it would take about 2 counters to perform the count. The inventory cycle count team has established a closed-loop process to guide their cycle counting program. Central to the cycle count is establishing an inventory accuracy goal that is challenging and attainable, keeping in mind that 100% accuracy is the ultimate objective. Significant improvements in inventory control accuracy come from finding the causes of inventory variance and eliminating them. A detailed description of each of the cycle counting steps is as follows. 1. Select the cycle counting items. Conducting a cycle count starts with selecting the items that should be counted. For the first count, the count teams should reference the block quantity of items calculated to be counted for each day for each classification. Next, for each classification, a block quantity of actual items are selected for that day's count. For the count on day 2, the next block of items is selected for each ABC classification. By the end of the cycle, all items that are in the classification should have been counted. Sometimes the cycle counting team may add items known to have serious balance discrepancies or problems to the list of cycle counted items. Step 2, generate cycle count documents. In this step, we're going to be generating the documents used to record the physical counts for each block of items by classification. Count sheets show the item codes, descriptions, locations, and spaces to record the actual counts. It is optional to show the current book balance record. Step 3, conduct the cycle counts. The cycle count sheets are distributed to the counters. The counters count each item and record the results on the count sheet. Normally, a set time is defined, such as 1 hour, during a period of planned inactivity to facilitate count reconciliation. When completed, the counts are returned to inventory control. The cycle count audit team reviews each count against the book inventory quantities. If a count occurs and it is within acceptable tolerances, the item is designated as correct. The item is then adjusted to synchronize the physical and the book inventory. No recount is necessary. If the count falls outside the acceptable tolerance, the item should be recounted before an adjustment is made. Step 4, perform the inventory analysis. In this step, the cycle count team investigates all items that were found out of tolerance for that day's count. These items undergo a detailed audit to find the cause of the error. An audit trail listing the transactions between the last and the current cycle counting dates is a valuable tool to help find the cause of the problems. Determining the root cause of errors is detective work that takes patience and curiosity. Inventory errors can be the result of a host of reasons, from poorly designated forms, untrained people, and carelessness to poor documentation control. Once all count reviews are completed, all adjustments to the booked inventory is then made. Step 5 in the process is eliminating the cause of error. This step in the cycle counting process is focused on communicating the cause of errors to the person or persons responsible for the problem. Steps should be taken to ensure that the chance of the variance reoccurring is eliminated. And finally, step 6, revise the cycle count data. Based on the results of a root cause error elimination step and ongoing counting, the cycle count team should revise the cycle count review intervals. There are two key indicators in this process. One, over a period of time, the number of variances should decline. And number two, the level of actual inventory accuracy should increase. This step occurs through a management decision to change the review interval by decreasing the variance probability on the spreadsheet that we saw on a previous visual. As the variance value decreases, the account frequency or weekly count will increase, and the number of cycle counts to perform daily will decrease. The goal is to reduce the probability of error to meet the desired inventory accuracy levels by ABC classification. Once the item numbers and count intervals have been defined for all three classes of inventory, inventory control can then assemble the contents of the cycle count sheets to be used by the counters. The sheet should, at the minimum, contain the following data elements needed by the cycle counter to identify the items to be counted. To begin with, many companies will place cycle counts and problem counts on the same worksheet. A problem count area enables inventory control to receive a count of items that had problems in their accounts, such as a stock out, incorrect material, items in the same family as a problem item, and so on. The number of items appearing on each count sheet should correspond to the capacities of the counter. So if a counter can count 40 items in the allotted time, then the count sheet should have at least that number of items. Any uncounted items are simply rolled over to the next day's counts. On the count sheet itself, the following data is useful. The location of the item, listing of the item numbers to be counted, description of the items, space for the counts to be entered, tolerance values to assist inventory control in making count decisions. The minus and plus signs in the tolerance simply states what is acceptable tolerances from the target. And finally, any reason code for actions taken. Any acceptable variances will be adjusted in the computer system through an inventory transaction. Visual 21 illustrates an example of a reason code table used by inventory control to identify the type of unacceptable inventory variance that was unearthed during a cycle count review. In the analysis of a previous cycle count, inventory control found that there were a total of 38 items that had variances beyond their tolerances and required further review and root cause analysis. Inventory control then identified the sources of possible errors and assigned the variance counts to a reason. From this vantage, inventory control could then examine each instance of error and search for ways to eliminate it from recurring. These variances then remained unsolved at the end of the process, or those variances rather that remained unresolved at the end of the process would then be used as the variance probability for the next calculation of the next cycle count. The most important aspect about the formula used in the development of our cycle count is that it is dynamic. For example, perhaps the central reason for cycle counting is determining the root cause of count variance and validating inventory accuracy controls. As the sources of variances are eliminated, hopefully the probability of variance will accordingly decrease. For example, let's assume that inventory control is able to reduce the weekly variance on A items from 20 to 15. The results of the change are as follows. The frequency to complete a count of all 2,000 A items goes from a little over 5 weeks to almost 7 weeks. The number of counts per year drops by over 14,850 units. Daily counts drop from 79 to 59, requiring 1.49 counters versus the former rounded to 2 counters. The reason for these changes is simple. As the probability of count variance moves towards 0%, the need to perform a complete cycle count of the full 2,000 items decreases, while the number of item counts each cycle also decreases. Using probability in the development of the cycle count also exposes serious defects when compared to the heuristic model that we had viewed earlier in the presentation. The source of the gap is that while cycle counting uses probability and it's dynamic, the heuristic model is static. For example, if indeed the cycle counting program had succeeded in reducing the probability of error for Class A items from 20 to 15, the gap between the dynamic cycle count and the heuristic static would grow. The reduction in probability would automatically adjust the cycle counting program, while it would be up to the planners to manually make the change on an heuristic model. The gap between the two models is visible below. In this situation, A items have an inventory variance probability that has been reduced to 15, which results in about 7 cycle counts per year. When compared to the heuristic, the probability model has cut the number of cycles by about 5 a year. In addition, the number of Class A items counted for an entire year has declined by a little over 9,000 items, 182 counts per week, and 37 counts per day. An important result is the reduction of 1 counter per day that could be freed up to perform other tasks. An effective cycle counting program provides a number of significant advantages. To begin with, cycle counting assists in the maintenance of a high level of inventory accuracy. When the firm depends solely on a yearly physical to adjust inventory, variances can go unadjusted for a long period of time because the focus of the cycle count program is on those products with the most transactions. Repeated review ensures a high level of accuracy. Additionally, an effective cycle counting system enables companies to abolish the expense in operations caused by the disruption of the annual physical. Finally, the real benefit of cycle counting is the information provided to inventory controllers, enabling them to investigate and eliminate the root cause of why inventory balances or variances occurred at all in the transaction flow. This total quality management approach focuses the entire inventory control function on continuous performance excellence. This concludes our presentation on the cycle counting program, and good luck with achieving your inventory accuracy objectives.
Well, thanks, David. We've actually saved some time for questions and answers. We did have a few come through already, so if you don't mind, we'll stick around here for more minutes after the hour just to get to some of the questions. And if you have more, please feel free to send them in. As a reminder, to do that, you can look on the toolbar for GoToWebinar. There'll be a questions box. You can type it in there and click send. We did have somebody ask if they had the PowerPoint. If you need it, please email editorial@apics.org. That's editorial@apics.org. And we'll be sure to send you a copy. Okay, David, so I know one of our first questions came from Ilaria, and she wanted to know, how can you determine the tolerance for item variance?
That's a good question. Usually we're going to be looking at the item classification, which will help us significantly. There is a recommendation that's an industry standard that the tolerance should not exceed positive or negative 3. So as you can see, it's very limited. You shouldn't be going to 5, 6, and 7. It does absolutely no good to improve your accuracy. So between 1 and 3, and again, as you have more important items, such as items that are consumed every day in production or sold, Your top items should have as low a possible number, while ones that are slow-moving would have a much larger variance. Again, the important thing to think about is that when a cycle count is done and an item count number differentiates from the book, does not mean that there is a massive problem. That variance would have to be checked against the tolerance percent. If it falls inside the tolerance, it's okay, and just a simple adjustment would have to be made. No need to go through massive investigations of why that small variance had occurred. On the other hand, if it exceeded 3, either plus or minus, we would need to go through a review process to try to find the root cause of why that error had occurred to begin with.
Great, thanks, David. Before I move on to the next question, I will repeat the email for the slides. It's editorial, editorial@apics.org. All right, then our next question comes from Matthew, and he wants to know, is a Pareto analysis the best way to figure out what items should be A, what should be B, and what should be C?
You could. There's a variety of different techniques. Usually computer systems, kind of begging the questions nowadays, will calculate those things for you. Usually there's more than 2 criteria that is used to establish what your cycle count, or excuse me, what your item classification should be. For example, a very common set of criteria is quantity and dollar value. So items that have sold a lot and have high value, for example, would be items that we'd classify as an A item. Even those items that could be considered commodities, if their transactions and dollar values grow high according to a specific floor that we would want in our ABC classification scheme, they would be assigned as an A status. So often computer systems will have the ability to place in multiple parameters that will assist you to actually come up with those. Or you could do it manually on a spreadsheet. The goal, however, is to determine what are those value criteria that you want, and it could be different per business, to establish what is indeed an A item, a B, and a C. Mostly the base is, however, how many times that item is transacted. And the reason for that is simply that the more times an item goes through transaction, the greater the probability of error.
Great, thank you. And we've got a lot of questions about how often you should update your plans. So to be more specific, first, Hans asked, how often would you revise this ABC classification?
Well, most computer systems that I've worked with and talked with other industry folks, regrettably, the key revolves around the cycle count interval. Establishing the ABC classification is pretty straightforward, and sometimes it's done automatically for you. However, the interval is not. And there's good reason for that, because computer systems nowadays apply to many different types of industries. Regrettably, however, they usually leave that field blank in the item maintenance screen and expecting you to fill that value in. Now, the advantage of having using the formula is that you could set up either in a spreadsheet or if you have the time and finances to create an automatic creation of your ABC class and counting intervals online. It would be similar to reorder points. A lot of computer systems make you do the reorder point values manually, specifically the demand side. Today's computer systems are smart enough to do the calculation of the reorder point automatically, which means our reorder point can change on a daily basis. Same thing could happen with the cycle count. You have the formula to help us calculate the variance. You've placed in the target inventory value that you want per class, and the system then calculates the interval. And again, it could be updated on a daily basis. The idea is to get as close a control as possible in your counting.
And so really, how often should you update the variance probability per week?
Again, the way I would look at it is every day. The information is coming in, especially, think about it, on the A-class items. The C-class items are ones that have a declining amount of transactions, where the A's have a lot more transactions. Those are the ones that we want to capture, the ones that would have the most probability of having an error. In this case, if you had it set up with a computer, it could validate the database and calculate for you on an as-needed basis what the new interval should be. So I don't think you should restrict it. Counts are established by the inventory control function by looking at the ABC classification and simply assembling a block from that ABC classification, entering those on the account sheet, goes out for counting, comes back. Now the next day, they will prepare another sheet, and it could be a whole bunch of different numbers because of the changes that have occurred in transactions since the previous period. So daily, weekly, monthly, whatever would fit the needs best of the company.
Great, thank you. And before we move on to your next question, I see Michael asked if we'll be sending out a copy of the presentation. And we will be sending out a copy of the recording. We've recorded this whole presentation, and we'll be posting it online next week. And everyone who attended live or who registered will be receiving an email with a link to that recording, so you can go back and review this as many times as you want. Our next question comes from Elizabeth, and she wants to know if you have a rule of thumb for how much manpower companies should devote to inventory counting.
It's a good question. The standard out there, in other words, what I've read in texts, is that a counter should be assigned about 40 items on a count sheet. That should correspond to a basic, and again, depending on your inventories, what the nature of those inventories are. But that should correspond to about an hour to an hour and a half worth of counting. And it depends on how your business is going to work. Some will do it, the cycle count right away in the morning, and all hands are on deck, including some office folks. The goal being to complete the day's count. Others, in other words, there's no transactions going on, and it makes it easy for reconciliation. However, with today's modern computer systems, the business can keep running and the cycle count could take place. I've experienced companies where there is a permanent employee who does nothing but cycle counts day in and day out. So it depends on the needs of the organization and how you want to approach your cycle count program. So there's no standard rule of thumb. It could go any way you like.
Well, thank you. Our next question comes from Steve, and he's asking, besides the reduced counter required when the accuracy goes up, what other stats can you present to upper management to show them that your cycle counting program is improving over time?
Well, what should happen is that when your cycle counting improves, the amount, one of the big is that your amount of stocked inventory should go down. The target at this, I think, would be the safety stock. We have safety stock because of variability in demand and supply. We also have variability in the warehouse, and that's what we see with our variance checking. So that as our possibility of error declines in the warehouse, those errors that we've incorporated into our safety stock calculation can be decreased. So we can see some improvement in the inventory costs. Another huge area is that obviously improved cycle counting will improve the stockability and availability of items in the production floor and for customer service. So the closer you come to the inventory targets, the better you can service your customers or supply product to inventory product, that is, to your production force or production functions.
Great. And I think Tammy here has a follow-up question to that. You mentioned that some companies have a full-time cycle counter. Should that person also be the one doing the adjustments?
No. Which that person, I even been in one where they had temporary help doing it, believe it or not. Or they've hired a high school or a college kid to do the counting. It's just simply counting. Obviously, there's some product knowledge, but that product knowledge error should be corrected so that fillers don't make the same problem when they're doing the counting. The count sheets are the key for what that cycle counter is doing. That should go to an assigned audit team in the inventory control department. It'll be their responsibility to go through the cycle count sheets, review them against the booked inventory, and make judgments, basically associated with the tolerances of whether or not that the cycle count needed to have a financial adjustment or actually needed to be reviewed for correction. So, for example, for a high volume item such as a commodity falling within the variance, we would probably simply have the inventory control function make that change to make it correspond to the transaction that they had seen in the past to balance that inventory out. And that's as far as they would go. No sense going through, again, an investigation of why that error could occur, because you could run into the situation where you had a negative one count and a negative at a +1 and the next count, they'd balance themselves out. So we'll see that again with very fast-selling items, and that's really the advantage of the tolerance, is to be able to separate the items that don't really need to have review from those that do need to have some review and correction so that that error does not occur again.
Great. And Thomas quickly asked if we could go back to the slide with the count frequency formula. Are you able to flip back to that?
Sure.
Flip back to here.
Okay. Well, that's the example.
Okay. Great. We'll leave that on the screen for a few more minutes for you guys. Our next question comes from Carlos, and he wants to know how you recommend handling seasonal items. Like, for example, should they be done transactional counting mixed with probability-based counting, or is there a better method?
It's a good question. Seasonal items, I want to make a statement that usually a lot of times seasonal items are non-repetitive. I think of things like bathing suits, lawnmowers, things like that. I'm trying to think of that actually fit a season. And I think for a lot of times that those things do not repeat themselves year after year. They're changed or modified to meet new customer requirements. When you're in season, again, since it's a seasonal period, you don't have the recurring ordering that'll go on month after month after month. There's usually a seasonal buy that takes place, or a lot manufactured that takes place right before the season begins. The inventory begins to be drawn off, and usually by a production plan or a specified purchasing plan, items are bought, and control of those items, unlike an ongoing item, is not that crucial in the sense that take like something like a pair of shorts, or that is for the summer, or anything in apparel has a life cycle to that apparel. And I know a lot of guys like myself want to go buy my shorts in July, and they're gone. They don't exist anymore. The new materials or clothing for the fall has now arrived in the shopping store. So usually keeping those records up to date is not as important as it is in an ongoing, because there's usually a build or a production plan that's governing really how much you're going to be making. And from there, when it runs out, it runs out. The thing important, they could be important for having accurate counts, could then be for pushing inventory in the distribution channel, things of that nature. But I think maybe if you're interested in counting, for example, if you had a season of, let's say, 3 months, and you wanted to count within that time period, that probably one of the other methods where you're counting from the beginning to the end of a location or of an item, family or something would probably be adequate.
Great. I'm going to flip back to our Q&A slide while we answer our last question. Our last question comes from Gino, and he wants to know how are the desired accuracy levels chosen? Are they randomly selected, or is there a rule of thumb?
Yeah, the standard APICS rule, which is the standard industry rule, is you'll find in almost all texts, is 96%. That's the starting point. So anything below that is considered that you're in deep trouble. And so remember, we're looking at a target, not what actually is. So our actual may come in at 80%. And the APICS standard and the standard you'll know for almost all ERP systems is much higher than 80%. In fact, the minimum is 96. That's why in our example for the Class A's, I chose 99%. Because as you know, for an ERP system to work effectively for inventory management, we have to have as close as possible to perfect inventories. So again, if you remember in the ABC class that I had before, I had the A items, I think it was at 99%, the Class B's at, I think it was 98, and my target for my Class C's was the base minimum of 96%. Okay.
Great. Well, thanks, David. That's all the time we have today. If your question was not answered, we did have a lot of really good questions come in, or if you think of one later, you can contact David at the email address on your screen. Also, I recommend that you check out the, again, September-October issue of APICS Magazine, which has David's article, has a lot of these charts and equations in there for you for reference as well. So on behalf of APICS, we'd like to thank David for his time today and all of you for joining us. We hope you'll mark your calendars for our next APICS Extra Live, which will be December 8th. We'll be posting that to our website probably within the next week or so you can register for that. All content and materials included in this edition of APICS Extra Live are the property of APICS and are protected by the United States and international copyright laws. All rights are reserved. Thank you so much for joining us and have a great rest of your day.